Hello everyone, welcome you all in another lecture of structural analysis. We are looking into strain energy method. Myself Mr. Aasif Baig, Assistant Professor, Civil Engineering Department, Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur. So friends, in the earlier class we have started this strain energy, in which we have seen the numerical of the portal frame having a concentrated point load over the span BC. So now the question is asked to calculate the horizontal thrust as well as to draw the bending moment. The numerical is given where EI is constant, AB, BC, CD members are having the length of 4 meter and BC carries a UDL of 20 kN per meter. A and D supports are hinge support. So we have to determine the horizontal thrust and we have to draw the bending moment diagram. So we have to calculate the bending moment. Okay. So two things is asked in the questions. So we will calculate first horizontal thrust and then we will calculate the bending moment, over which we will draw the bending moment diagram. Okay. So very first calculation is to calculate the reaction. So reaction is at A, which is called as VA, and reaction at D is VD. So these two reactions we have to calculate. So as the load is symmetry load, so the total load will be divided into two, and that will be reaction at A and reaction at B. So total load is W into L, so 20 kN per meter over the span of 4 meters. So W into L divided by 2. So we are getting the VA as 40 kN and VD as 40 kN. Okay, so these are the reaction at V and at VA, at A and at D. Okay, now horizontal thrust we have to determine. So this HA is equals to HD is equals to this H. This H we have to calculate. So for which we have to draw the table. So table consists of member. I have write it down as short due to the lack of space. Then origin, then limit, then moment calculation, then we have to partially derive this moment with respect to this H. So del M by del H we have to calculate. Why we are calculating this M and del M by del H? To put that value into this given equation. So this equation is given in strain energy method. This equation is derived equation. So this at this M and at this del M by del H we have to put these two values. Okay. So accordingly we will calculate first. First we will talk about AB. So AB member is this one, vertical member AB having the length of 4 meter. So origin of this A is at this point. Okay. The limit of this is 0 to 4. So the 0 is this one, and B at B this distance is 4 meter. So limit is 0 to 4 meter. Now we have to calculate the moment. So what we will do, we will make the section at this point. Okay, at a distance of x from A. Now which moment will act? First we will talk on this force, VA force. So VA having the intensity of 40 kN, but this is passing through the axis and having no distance. So this moment will be 0. Only one moment will be act, this H. So this H is rotating in anti-clockwise direction. Sorry, H is okay. So H is rotating in anti-clockwise direction at a distance of x. So the moment will be minus h into x. So if you drive this with h value, so the remaining value will be minus x. Now similarly we will talk on the member BC. Member B to C, the origin is B, limit is 0 to 4, limit is 0 to 4. Now we will calculate the moment. So for moment we will make a section at a distance of x from B. Now at this section, what kind of moment are acting? So first moment is this VA, this vertical VA with this distance x. So VA into x, it is rotating in clockwise direction. So VA into x will be positive. The value of VA is 40. So we will write this as 40x. Then this h into this 4 meter distance. This h is situated at this 4 meter distance. So this h into 4, and the rotation is anti-clockwise. So this is minus 4 into h. Then when UDL is acting at this point. Okay, this intensity of this UDL is 20 and the distance is x. So this will be 20 into x, which will be situated at a distance of x by 2. So 20 into x by 2, the total value is 20x square by 2 and the rotation is anti-clockwise. So this will be minus 20x square by 2. So we can write this as 40x minus 4h minus 10x square. Okay, this will get cancelled. This will get cancelled. This will be equals to like this, 40x minus 4h minus 10x square. Okay, now we will write this moment with respect to h. So this will be equals to minus 4. Okay, now we will talk on the member CD. So instead of going with this CD, we will take the member, this member as DC. Why? Because if we go for this section from this direction, so the whole loading will be come into the picture and the calculation will be goes complicated. Okay, so instead of going this CD, we will go in the DC direction. Okay, so instead of writing CD, I am writing this as DC and origin will be D. Okay, now we will make the section at a distance of x from D. Limit is 0 to 4 and the moment will be this VD will passing through the axis, so no moment will be there, but the moment of this h will be there. So this h is rotating in clockwise direction at a distance of x, but this h is situated right side of the section. Okay, so at right side of the section we know the clockwise rotation is negative. Okay, so this will be minus hx and del m by del h value is minus x. So this is what we have calculated by taking the section on all the members and putting that value into the table in terms of m and del m by del h. Now equation we know sum of integration of m del m by del h into dx is equals to 0. So we will put this value into this value into the equation of all the sections, okay, of all the members. Okay, so first we will talk on member AB. So member AB having the moment minus hx, del m by del h value is minus x into dx plus integration of 0 to 4. The BC member having moment 40x minus 4h minus 20x square by 2 divided by 2 into minus 4 into dx plus DC member having the moment integration 0 to 4, moment is minus hx into minus x del x is equals to 0. Now from the equation we can see that minus hx into minus x is 2 times. Okay, so 2 times 0 to 4. Now we will calculate these boxes, these brackets. So minus x into minus hx, this will be plus hx square into dx plus 0 to 4, 4 into 40, that is minus 160x minus 4 into minus 4h, that is plus 16h plus minus 4 into this minus 20x square by 2. So this will be 40x square. Okay, so after calculating this integration, we will getting the value of 2 into hx cube by 3. This how this value are coming, that we have discussed in the earlier class. Okay, so for the reference I have putting the link of the previous numerical in the description of this numerical. Okay, you can go through that. So hx cube divided by 3, 0 to 4 plus into 160x square divided by 2 plus 16hx plus 40x cube divided by 3, 0 to 4. So after calculating this, we are getting the value of h is equals to 4 kilonewton. So this, by taking this h 4 kilonewton, we will calculate the moment. Okay, so another unknown is bending moment. So in the bending moment calculation, we will take the moment of this particular section. So first we will talk on the member AB. So section AB, moment at x we know minus hx. Okay, so minus hx, now h, value of h we know, that is minus 4. So this will be equals to minus 4 into x. So at x is equals to 0, this section we are talking about. So at x is equals to 0 at this point, A point. Okay, so at A, x is equals to 0. So we are calculating the moment at A. MA we are calculating. So at x is equals to 0, mx will be 0 because this minus 4 into 0 will be 0. So MA is equals to 0. Now at x is equals to 4, okay, this 4. So that 4 is at B point. So whatever moment we are calculating, that moment will be MB. So at x equals to 4, the mx equals to 60 minus 60. Minus 4 into 4, that is minus 16 kilonewton meter, and that moment is nothing but moment B. Now we are talking about section B. Section B is having the moment mx equals to 40x minus 4h minus 10x square. This value 40x minus 4h minus 10x square. Okay. Now we will put the value at x equals to 0. At x is equals to 0 means at we are talking about B. So moment B we are getting. So remember one thing, while calculating the moment B, which is already we have calculated in section AB, MB we have calculated already in section B. Whatever the value of MB we are calculating in section B will be the same which we are getting in section AB. So MB is equals to minus 4 into h. This will be only remain because this x is equals to 0, this x is equals to 0. So when we will put this value of h at this point, so minus 4 into 4 minus 16 kilonewton meter. So you can see the similarities. Okay, this should be same. Moment B and moment B at section AB and moment B at section BC should be same. Now at this BC point we know there is one UDL, and we know the maximum bending moment will occur at the center. So at center we will calculate the bending moment, that will be the positive bending moment. So at x is equals to 2, if you put, so 40 into 2, we are putting the value of x as 2. So 40 into 2 minus 4 into 4 minus 10 into 2 square, we are getting the positive bending moment, that is 20 kilonewton meter. Now at x equals to 4 means we are calculating the moment at C. So at x equals to 4, MC moment at C will be equals to 40 into 4 minus 4 into 4 minus 10 into 4 square. We are getting the value of 16 kilonewton meter. Now we will talk on this last section, that is DC, section DC. So mx we know minus hx. So we will put at x is equals to 0. It means we are calculating the moment at D. So this will be equals to 0. And when we will calculate moment at C, which is we are getting by putting the value x is equals to 4. So the moment is, if you calculate this should be equals to the moment which we have calculated in section BC. This should become minus 16 kilonewton meter. So moment at A we know, moment at B we know, moment at C we know, and moment at D we know. So we will calculate the bending moment. So in bending moment at AB section, this is moment at A is 0, moment at B is minus 16. Okay, so minus 16 we will rotate in minus 16. Okay, minus 16. So this will be negative on this side. Now again on this side minus 16. Then this is again minus 16. Okay, above this point. And at center this is 24 kilonewton. So we will just draw like this second degree curve, parabolic shape, and to observe this 24 kilonewton positive bending moment. Okay, now at C minus 16 kilonewton meter moment is there, and at D 0 moment is there. So this is what the final bending moment diagram we have drawn. Okay, so at this point we have learned to calculate the horizontal thrust and how to calculate the bending moment. Okay, so in next lecture we will see what will happen if this loading condition is unsymmetric or which is acting on the column. So that frame will be sway frame. Okay, so how to calculate the horizontal thrust in the sway frame, that we will see in the next lecture. Okay, so on this strain energy method, this is the second topic which we are covering, and for the reference of first topic I am putting the link of the first video in the description of this video. Okay, so till then, thank you very much.